There are a few different types of clusters of stars that you can have in the universe and in galaxies. And in this video, I wanted to focus on open star clusters as one of those particular types of clusters of stars. So firstly, they're groups of stars. So here you've got a nice open cluster of various different types of stars in there. So you get some red stars, some white stars, blue stars, and this is an open cluster. And the key difference between an open cluster and something like a globular cluster is down to its shape. So a globular cluster, as you can quite clearly see on the right, has a more spheroid shape. So it's kind of almost like a sphere of stars with a higher density of those stars in the center, and it kind of decreases density as you get out. But an open cluster doesn't necessarily have that same shape or structure. It's a bit more scattered about, or more, I suppose, chaotically distributed. Maybe that's not the right way, but there's no fixed structure to an open cluster in comparison to what a globular cluster might look like. And the other important difference is the number of stars in them. So a globular cluster can have up to 1 million stars in them. So these are very large structures with many, many stars, whereas an open cluster, you would typically have 10 to 100 stars in, maybe a bit more. So they have a lot less stars in. So orders of magnitude less stars than a globular cluster. Now in a globular cluster, because there's so many stars there, and they are quite densely packed, specifically towards the center of them, then they're very close to each other. Those stars can interact gravitationally. You have lots of binary systems where stars are orbiting quite closely around each other. And it also means that things like planets are unlikely to be found there because there's so many stars interacting with each other that they would actually remove any planets that may have formed. They would get scattered out and thrown out. So globular clusters, the dynamics are different. And in an open cluster, they're not gravitationally bound to the cluster or to any other star particularly. So these stars are free to move around. They kind of almost disperse these clusters over time. So in time, that cluster would not be a cluster anymore. Those stars would move independently out of it. Whereas with a globular cluster, they are gravitationally bound to the cluster and they can remain like that for a long period of time. So this is a big difference between the two in the movement and dynamics in an open cluster and a globular cluster. Now, with an open cluster, you're going to have recent star formation. A globular cluster, not so much. So a globular cluster is very old. These have existed potentially, or they potentially have some of the oldest stars in the universe at the current time. So these are old red stars, whereas a open cluster, they've formed more recently. They're going to have younger bluer stars. And you can actually see with the Pleiades, it's very obvious there, you've got a lot of bright blue stars. The globular cluster on the left hand side, you can see that there is a population of predominantly red stars there. There are a few blue ones which are a bit bizarre because they are known as blue stragglers, which in theory shouldn't necessarily be there, but they can form due to the close proximity of stars and they collide basically. But as a general rule, the population of a globular cluster is older and redder compared to an open cluster. So if you go to the HR diagram, you've got the surface temperature of stars plotted against their luminosity, and then you have this main sequence down the middle. And depending on the size or the mass of that star, it will fall somewhere on that main sequence. So the larger the star or more massive the star, it will have a higher surface temperature and it will be more luminous for a main sequence equivalent. So it would be basically bluer compared to a lower mass one, which would be down on the red part. So here you've basically got stars that are younger. So in order for you to have a blue star, they burn through their fuel a lot faster than a smaller star. So if you have a blue star, it means it's actually younger. And as they age, they then become redder. So the point here is if you've got blue stars in a cluster, it means they're going to be young. So a globular cluster is predominantly these redder stars, which means that they don't have those younger blue ones in. But they will get older, also they will get redder as they age. So a globular cluster, you'd have a population which would be redder kind of on that part of the HR diagram. And it's worth noting that like for sun-like stars, they will go through a red giant phase of their evolution, which means they move up and to the right of the HR diagram, so they become into these red giant phase, which obviously makes them redder. So you'd expect to see stars in that part of their evolutionary phase with those clusters. Now, open clusters also are going to more likely have higher metallicity stars. That means that they contain elements heavier than hydrogen or helium. So when we talk about metallicity or metals in astrophysics, we're talking about elements that are heavier than hydrogen or helium. And stars in open clusters are likely to have higher ratios of those heavier elements compared to stars in a globular cluster, which would be lower metallicity. Now, why is that? Well, in order to get your heavier elements, they have to be formed inside the stars or during the end part of a star's life, like a supernova or things like that. In the early universe, they wouldn't have been around. So stars that formed very early in the universe, those first population of stars, are going to have much lower ratios of metals in them. So globular clusters, because they're very old, they would have formed earlier on. They have these population 2 stars in them. And in order to get your population 1, these are the next generation of stars which would have formed in the remnants of the first lot of stars that formed. And an open cluster, because they're more recently formed, they're going to have formed in an environment that already had higher abundance of these heavier elements. So that means that they are likely to have an increase in their metallicity compared to the other type of cluster. Now, when they actually form, they're forming from a collapse of these giant molecular clouds. So you have these giant molecular clouds, and these collapse. Now, it doesn't just form one star. As it's collapsing, it will fragment, and you'll get stars forming locally in that cloud, and then that's what gives you your cluster. So depending on how large that cloud might have been to start with, will denote how many stars you're potentially going to get, and as it fragments to form those stars. And because they formed together around the same sort of time, the stars themselves are likely to be of a similar age as well. So they're going to have a population of stars which have formed together. So they're almost going to be siblings from the same sort of environment. And then over time, they will kind of drift apart. But in the beginning, they're going to have formed together and will likely be of a similar age. Now, these clouds collapse as they enter spiral arms. So in these spiral galaxies, you've got spiral arms, and the gas, dust, stars, and all the other material in the disk plane is orbiting around the center, and it goes in and out of these spiral arms. So the spiral arms are waves, they're like density waves, and the material can go in and out of them. So as it goes in, the density is high, so they get compressed, and then when they leave, the opposite happens. But as these clouds go into the spiral arms, or the gas goes into the spiral arms, then they will collapse, and that's when you get the stars forming. So these clusters will typically form in and around the spiral arms, and then they will move out. So when you look for open clusters, they're typically found in or in between spiral arms. And it's worth noting that actually that you're not really going to find these out of the galactic plane. So if you go above the galactic plane, because these spiral galaxies are kind of disk-like, you're not going to find these open clusters outside of that because there's no gas there for them to actually form. So they have to pretty much be in this sort of environment here in these galaxies. In contrast, globular clusters are orbiting outside of these galaxies. So if you look kind of edge on at a spiral galaxy, you can see the disk-like structure there, and these globular clusters are sitting outside of that, and they're orbiting around the outside of galaxies. There's no gas there. Again, that's why they've got no recent star formation, and they're almost like satellites, and they would have formed when the galaxy formed very early on, which is why they're older as well. So a different environment to these two different types of clusters. They're found in different locations. And also, they're not typically found in elliptical galaxies. So elliptical galaxies don't have any gas in them, so you're not going to have any recent star formation. So generally, you won't find an open cluster in an elliptical galaxy. They're going to be mostly confined to your spiral galaxies or spiral bar galaxies, or maybe irregular galaxies which have got gas in them. So again, different sort of environment and different location to what you might find your globular clusters. So thank you for watching, and if you enjoy, then check out some of the other videos.